Hello everyone, so in this video we will be completing our transformer theory series by understanding transformer decoder. Okay, so this is the entire transformer architecture, and in the last video we have seen the encoder part. In this video we are going to see this part, which is the decoder part. Okay, so let's get started. So obviously, as I said, this is the decoder, and there are four things that we're going to discuss. Even in fact there is this five, but this is very simple, linear and softmax. So first of all, we're going to see the positional encoding, which is a little different in this case, and that's why I'll be going and explaining this part. Second, the mask multi-attention, multi-head attention. Basically it is masked, and again we are going to see how we are going to use it. Okay, and add and norm we have already seen in the previous video, so it is just a simple manipulation. Third, there is a multi-head attention over here, which is basically your cross attention, so we will be giving some importance over here. Finally, a very simple feed-forward neural network, and finally this fifth layer, which is also again very simple. Okay, so we will be looking at into the entire architecture. We'll be doing all the four things that I have said over here: positional encoding, mask, which is the second one, masks, attention over here, then the third one is cross attention, and feed-forward neural network. So let's first start with our positional encoding. And what I want you to know is that this is a little involved in this case. Okay, so let's say what we are doing is a chat bot, something. Okay, let's say we are going to making a chat bot, which means you give a message and the bot is supposed to give you a reply. Okay, so this is your message and this is your this is the reply that the chatbot gives. So let's say you give the message, my name is John, and pad is basically your padding token. So let's say obviously when you are training a model, you'll be training with more than the longest, for example, you'll be training with sentences that are longer than the present sentence. Okay, so let's say there is another sentence that is six words, so that's why six words are there, but you have a sentence that has only four words. So what you do to make it six, you add two padding tokens. Okay, so we'll see how we will be taking care of this in cross attention, but don't worry. Okay, first what we are giving to the model is my name is John. Okay, and then it will say, the model is supposed to say, how are you John, a question mark. Correct, is that is exactly what you want, right? You say to the model, you say to the chatbot, my name is John. What do you expect the chatbot to say? To say, how are you John? So this is how we are going to train. Okay, let's see how this training will take place. So first thing what we are going to see is the positional encoding. So what you're giving here is a how are you John. So that is your this is what you want the model to predict. So how will the prediction be? So the prediction is going to be like this. Okay, so before I go into the prediction, this is just your, okay, let's say, so this is a word embedding plus positional encoding. Okay, so this has already been what to say, given to the model. That is what I have assumed. Okay, so let's see how that happens. Okay, so you are supposed to predict how are you John. So what you will do at the first time step, you will only give the word how. You will give the word how. Now the way you give it is by using word embedding and positional encoding. This is what I meant. And what you are supposed to predict, you gave the first word as input. What is the prediction? The second word. So you are supposed to predict R over here. R first, the word R. Now that you have predicted the second word, does that complete the entire prediction? No, obviously you have to predict the third word. So what you do, you add both of this. You add both of this and make it one input. So now how was the first word and this was the predicted word. Now both of these are given as input, and figure out, and once these two are given as input, this is supposed to be the output, and hence this is output. So here you will give how R. Again you will be giving the word embedding and positional encoding, not just words, because words won't be understood by the model. You will have to convert it into numbers. So word embedding and positional encoding. So this is then again what to say, you will be asked to predict the word you. Okay, again, this the last word? No. So you will have to give this, the whole thing, whatever you gave is the input, and then figure out the word John. And then again lastly you will also have to predict a question mark. So you can see this is over here, how are you was the third one, and the fourth one was how are you John. And what was supposed to predict in the third one, how are you, third prediction was John, and the fourth prediction was question mark. Okay, so how does all this happen? So what we use is, this is the first mask. Okay, this is the mask that we use over here, that will be part of O1. What you say is, in the first one you only gave input as how, and rest everything was not given as input. So you have 1 over here which is corresponding to the word how, and rest everything else is 0. But in the second word you gave how are, you give the first and the second word, and so these two are 1 and these two are 0. In the third you gave how are you, so these three are 1 and this one is 0. And fourth you give all the words, right? You gave how are you John, and you give this entire thing to the model. So obviously this entire thing will be given at once because processing happens in parallel. So basically this is the mask. Now how it will be used, it will be seen in the next slide. Okay, so we have understood the positional encoding part, this part. Now what we are going to do is we are going to see the masked attention, which is this part. Okay, we are going to see this part, masked attention. So masked attention is very, very simple. What you do, you have Q, K and V. So here you will have Q, you will have your key, and you have your value. Okay, what was O1? O1 was the output over here. You can see output O1 is over here. So that will be given as input to the query matrix and the key matrix and value matrix, and you will have Q, K and V. So for the scores, what you do over here, you can see the scores. You will have the Q cross K transpose, which is your query and key, divided by the square root of embedding dimension. This is simple because this we have already seen in the self attention. What we have is the mask over here, which means once let's say your score is 4 cross 4, right? Remember 4 cross 4. Why? Because there are 4 words, and whatever the words are there in the first, what to say, sentence, you will have the scores as 4 cross 4. It is going to be a it's going to be a square matrix. Now remember the mask that I had shown you over here, the mask was triangular mask, which means this entire upper thing will be blurred, right? It's going to be a lower triangle mask, sorry, yeah, lower triangle. So which upper triangle will be completely blurred. Why do you do that? Because you do not want the model to look forward. Okay, why? If you see, if I'm going to predict the word, if I'm going to predict the word you, should I have access to the word John? According to this, no, because you should only look in the left. Okay, so that is why we are going to use this left to say mask, because everything else over here is 0, which means we cannot look into our future, right? We cannot look into the future to predict the present word. So that is the reason why mask is used. You'll have to study a little bit. This is not that easy to understand, but yeah, this is the idea. After that, same attention, weights is equals to softmax of scores, and then FV1. So till here FV1 is over here, this till here. So step number 3 was your attention, what to say, scores calculation. Finally you will have your final value FV, final value. This is for 1 because we'll have other final values as well. And then add and norm is very simple, you add. So residual connection, this connection over here, this one, this line is residual connection. Okay, so what it does is whatever is the output FV1, it adds the input O1 to it, and then finally you do an layer norm, and you finally get an output O2. Okay, I hope you understood. For third we'll be doing is cross attention. Okay, so which is this part. Let's go over here. This part is your cross attention. Okay, so what will happen over here? So this is again very simple, but one thing that you need to understand, O2, the query, you see over here, the query comes from down, right? But your key and value comes from the encoder. This is key, this is value, and this is query. Why? Because I fill in the blanks. How are you dash? Dash was coming in the decoder part. It is a query, it's a question. That's why Q. But key and value comes from the encoder part, and that's why you see query comes from O2, which is a part of decoder, but key, the value K, it is using encoder output, which is coming from over here. Encoder was here, right? Encoder over here, and same thing for the value. Encoder was on this side. Again, here also mask is there, but let me first explain this part. This is simple. If you remember, every time when we do attention, this is what we do. So what is the mask? Okay, remember when we started, okay, when we started, you saw my input was my name is John, and there were two padding tokens. If you can see over here, right? There were two padding tokens. I said, do we really need to take care about the padding tokens? Because obviously these are going to have some values, and these don't matter because this is there only to make sure that all our sentences are of equal length, which means this has no predictive power, correct? So if I am paying attention to the padding, it means I'm making very grave mistake. That is exactly the reason over here. Okay, if you see over here, cross attention mask, this padding token is not very useful. So what you say, wherever there is pad, I'll have 1, wherever there is pad, I'll have 1, and wherever I have some meaningful word, I'll have 0. which means that whenever the model, the mask sees 1, it will not consider it. Now how that happens is basically used in the softmax course. Now again, how that happens and getting too deep into it is not the idea of this video. I think I'll make another video for that, masks in transformers. But this is the entire idea. Okay, so what you do is you use a mask, and basically in the mask, this is only for the encoder stuff. Why? Because this sentence was given, this entire sentence was given to the encoder. Okay, so this is coming from the encoder side, this mask. And what is the reason? We don't want to focus on the padding token. Okay, finally you have the weights. Again, fv2 again over here, fv2, this is nothing but the weights into the value. And you have again add and norm, as you can see over add and norm. So you're going to have add, which is going to be this one, fv2 plus the input, which is o2. So fv2 plus o2. Finally you are going to again have a normalization layer norm, and then you figure out your o3. Okay, then after that it's very simple. Finally you're going to do a feed forward neural network, very simple over here, nothing great. You take you initialize to say a layer, linear layer. What you do, you remember this was the input, o3 was the input, so you do a fc of o3, you get ffo, which is the full feed forward output over here. But again you have to do add and norm. So very simple, you just add the output of ffo plus o3. O3 was the input over here, and then you do a layer norm of that, add 3, you get o4. Okay, so yeah, so these are the 4 things. This is again very simple, so I have not included. Basically you will have another linear layer over here, and then whatever o4 was there, you just pass that to o4. Okay, o4, and you get some output, and then you do a softmax of that. Okay, softmax of that, and finally you whatever you get is the output probabilities. This is the idea. This is very simple, I have not explained. So I hope you like the video, and this was the entire decoder logic. I hope you like the video in the next series. So this series is complete. Let's see if I make another video on masks, but I don't think I'll be doing that because I'll be explaining it in the practical videos. So I hope you like the video. If you like the video, please like and subscribe. Thank you very much, and bye.